the stage of industry track. We are looking forward to your great panel on the AM for pre-open healthcare. I would like to give the floor to our moderator for this panel, Sirin Asiri, and we look forward to hear more of you. I would encourage the attendees to post a Q&A for the panel, and as well enjoy the chat among themselves. Okay, I will excuse myself now.
Thank you very much, Malika, for the handoff. Thank you everyone for being here. I'm really excited for this panel and for this discussion about pre-op and healthcare application of additive manufacturing. I'll share with you my screen. Can everyone see it? Great. Thank you again for joining and for attending this panel. I'm really excited to share this with you today. I will briefly introduce myself. I'm Sirin Asiri. I'm a R&D engineer at Bone3D. Bone3D was created 3 years ago. We are based in Paris and also in Strasbourg in France. And we design, develop, and print different projects in the healthcare sector. We have 3 main projects that we develop, mostly anatomical models, training surgical simulators for surgeons to train on their skills, and also medical devices developed with 3D printing. We also offer the possibilities for hospitals and clinics to set up a platform inside the hospital to help them with their need in their facilities. So joining me today, there's Joyce and Eva. I'm really excited to talk with you today. Can you briefly introduce yourself? Maybe Joyce, you can start.
Yes, hello everybody. I'm very happy to be a part of this panel. I work at Materialize in the medical department, and we have a broad range of applications going from 3D planning for preoperative planning for surgery, but to also providing anatomical models, surgical guides for orthopedic and craniomaxillofacial surgery, up to patient-specific implants for orthopedic and craniomaxillofacial surgery also. And I'm a technical product manager there, so I'm heavily involved in the R&D of the orthopedic implants and the operational part.
Great, thank you very much, Joyce. Eva, can you introduce yourself, please?
Yes, hello. It's a pleasure to be with you today. I'm Eva, and I'm co-founder and CEO of Customy. Customy is a medtech startup that's specializing in patient-specific solutions for innovative surgery. We have started in 2016 with designing and manufacturing anatomical models, surgical guides, and implants for reconstructive surgeries. Then we moved the next step, and we have developed the software for 3D medical data processing and for collaborating between surgeons and bioengineers. I myself, my background is mathematics and computer science. And since the graduation for the university, I have been working in a number of IT projects. But what I always wanted to do is to combine the IT and medicine. And my dream came true with Customy. Thanks.
Great. Thank you very much to both of you. I'm really excited because we have different backgrounds and also different application that we will present today. So it's going to be a great conversation about all of this. For all of you who are watching, I don't know if you're all familiar with the healthcare sector, so I will briefly present the general process that you have to do to develop those different projects. The process usually starts with data acquisition. Typically, you have CT scans, MRI. Also for the dental application, you have surface scanning. Then you proceed by processing those images during a segmentation. The segmentation will help you isolate the region of interest and create a 3D model of this region. The segmentation is mostly now automatic or at least semi-automatic with different algorithm. I'm not going to go into much detail here. From there, you have your three-dimensional objects, and you start the design of your final project, your implant or your model or your surgical guide. Maybe you will add support to the thin structures or label your model, so you have a phase of design. And then the part that we are all familiar with is the printing. You prep your file, you slice it, you 3D print it with the technology, and the technology will depend on the application, and we will see about that later on. After that, you have a good part of post-processing, which is really important. We often neglect this part or not talk about it much, but it's really important, especially in the healthcare sector. It's gonna be a big part of the whole process. Then after that, this process will result in in your project: anatomical models, training models, surgical guides, patient-specific implants. I will talk a little bit more about the training models and anatomical models that we develop. At Bond3D, you have different surgical simulators for different anatomy, different specialties. We have I can show you, for example, one example of a simulator of nasopharyngeal swabbing for the PCR test, for example, and you have different training models for surgeons and students who are going to become surgeons to develop their skills. Anatomical model for visualization, and surgical guide and patient-specific implants that we are going to talk more today with Joyce and Eva. Let's start with surgical guides and the surgical planning. Now, the surgical planning starts at the beginning of this process with the segmentation. Since Eva, in your company, you developed a software for the data processing. Can you tell us a little bit more about the crucial steps and the benefits of the surgical planning?
Yes, thank you. So I think the medical data is starting point for all of us, as you said. And the next step, we have the segmentation process. So when you have the medical data, for example, CT or MRI, as we all know, is a stack of images, and we need to translate it and get from it and create the 3D structure. So we need to separate, for example, bones from the other tissues. And that's what happened in segmentation process. So basically, we had a problem at the beginning, customer, with that because it was a very time-consuming process, and it's a very crucial process because if you make any mistakes here, it will affect all of the next steps, the design, the printing process as well, because the device will be somehow broken or not correct. So because of the crucial moment here, we need to focus on exact separating the tissues from each other. And as I said, it was time-consuming for us at the beginning. So we were looking for some kind of solution for that, which would our needs and accelerate our work and fulfill our needs at that time. So we decided to develop and our own algorithms for that and create our own software. That our vision was born. And what was crucial, as I said, it really accelerated our work. So we could speed up that moment, that process, and have the great reflection of the 3D anatomical structure. So starting with the separation of the tissues, you need to create a 3D mesh of the structures, and then you have to make post-processing operations to make them smoother. And as a result, from this part of the process, you have the 3D virtual model of the patient. And this model, a customer, we can print it and it will serve as an anatomical model. Or it can be also a base for the next step for talented bioengineers to create the implants or surgical guides based on that model. So this is important step, and this is the base for the next one.
Awesome, thank you very much. Yeah, it's really interesting that you mentioned the different separation and how it will affect the next step. Can you maybe both of you talk a little bit more about the surgical guide, how this process apply to the surgical guides?
So from my side, it's like, okay, we create the anatomical model. In our process, we discuss with a surgeon what are the next steps to be done during the operation. And based on that, we create the surgical guides. So he needs to mark the points where, for example, osteotomy will be done. And based on that, then the next design process is started. How about you, Joyce?
Yeah, I think it's very similar. Obviously, we typically already prepare a planning first as well. So we get some input from the surgeon when we receive the images on the surgery he intends to perform. And our clinical engineers, on average, yeah, they have a lot of experience because they focus in one domain and they support multiple surgeons at one time. So to put it a bit black and white, they often see more complex surgeries of this type than the surgeon himself does because they support so many centers. So they will prepare a pre-plan, which makes it a lot easier also to discuss with the surgery what will actually be done with the surgeon. So they'll guide him through the process during a web meeting. And then based on his output, we can finalize the design of the guides. And then obviously we still need his approval to make sure that items like, will the guide fit in the incision? Are we taking into account the correct instrumentation you will use in the OR are all covered and discussed.
Great. Thank you, Joyce. You mentioned an important point during this whole process. It's important that we have we are planning this with the surgeon. We are not, the engineers are not on their own. Every step will involve the validation and the validation of the surgeon and the healthcare staff to make the best project for their application.
And I think it's important to also highlight that obviously there are also surgeries which the surgeon can plan on his own already. I mean, the co-planning from an engineer and a surgeon, that's happening for the very difficult and challenging cases like corrective osteotomies in both orthopedic and CMF area. But we're also supporting the planning of shoulder surgery. And that's more through a web interface where the surgeon can do his own planning. And then based on that planning, the guide is created afterwards. But there you do not necessarily need really a web meeting of an engineer talking to a surgeon to define the position of a shoulder base plate, for example. You also need to be careful of a surgeon's time. They're not easy to get in touch with. Sometimes they have a busy calendar, and some really like to do this web meeting, and others prefer just to sit in the evening behind their iPad, for example, and go through their plannings.
That's that. I'm sorry. That really an important point about the time of the surgeon for each step. He's gonna do.
We have the same experience, if I can say it, because from our side, the surgeons almost never have time for meeting, and it's really hard to catch them during the day because of their scheduled time at the hospitals and operations. So if you have the web platform which serves them as a planning tool for operation, I guess it's the best work. How can you accelerate your work at that stage? And one surgeon can plan the whole operation there. I think it's important for the whole process.
And Eva, you mentioned the platform. Do you need to train the surgeon to use this platform planning?
Yes, we only. we only plan the operations with surgeon through the platform. They have the virtual model of the patient. They point out the cutting, for example, of some kind of other operations steps, and we based on that we design the implants or the surgical guides or the anatomical models. It's really easy because we don't have to schedule our time from both sides. Sometimes there's time difference, so it's better to use the platform. Yeah.
It will simplify a lot of steps, especially
Yeah.
as you said, the surgeon doesn't have always the time to validate every step, and we are also on the time limits with surgical guides and implants. The surgery is scheduled. You have to work on the time limit. As a production manager, Joyce, do you experience different lead time for different projects? How do you manage those time in retrospective to the project and its emergency, if I can say?
For the clinical cases, you mean? Well, I think that's one of the shortcomings, probably still, that the whole process takes some time, that it's hard to support acute trauma, if not impossible almost. If they really want to operate within 1 week, it's for the orthopedic, I'm going to speak for my orthopedic background here, because there are differences in the CMF processes. It becomes very challenging because you need this back and forth communication with the surgeon as well. And then as soon as you go into the printing of patient-specific implants, obviously you have the full printing process that also just inherently takes some time. You have the heat treatment. Now, we rarely have have a discussion where this is a deal breaker. Because this is elective surgery, the surgeons can do patient expectation management and make it clear that they need to go through a process where they need to have some time. So then it's more in the oncologic setting that it becomes quite urgent. And then these are the cases where also the team internally will try to go the extra mile and then speed up everything a bit faster when needed. Although there I must say that quite often we can also schedule it nicely because those patients are undergoing radiotherapy anyway. So often they get their images up front and they still need a few weeks of radiotherapy sessions before they're fit for surgery. And then we can take that time to make the guides and the implants.
You do the whole process. Okay,
Yeah.
great. You mentioned about this process. I'm sorry, I lost my question. You mentioned the time can be a deal breaker. Sometimes it can be. Yes, I'm sorry. It can be due to the fact that the surgeon don't always know the printing technology that they work with to create the surgical guides, the implants. Do you work with surgeons that are familiar with the printing technologies? Do you sometimes find it that they have the experience behind it? They know about it? Or would you train them more about this aspect?
I think definitely not all surgeons know a lot about the printing process on its own. If they know about it, they have a small 3D lab. But then it's often with desktop printers for models. And we do notice that if we have surgeons on site for a training course, for example, or for a user group, and we walk them through the printing facility and explain a bit about the different steps that are being done in the process, that it's a bit of an eye-opener. Then they say, okay, now I get why it takes so much time. There's so much more to do. So especially metal printing takes a lot more than putting an anatomical model on a desktop printer.
Yeah.
And that's not so known yet, but I think that's up to us as companies to make sure that we explain it well to buy us some patients to process the cases.
I think it's very important what Joyce said right now, because the surgeons, I guess, sometimes think that 3D printing, processing, 3D printing is very quick and easy process, and you just like that have the models. And why it takes so much time to do it? And for example, in our cases, we have surgeons that, okay, sometimes we have 3 days for, pre-operative planning and for printing something for them. So it's really tight, and all time is, well, when we talk about some oncological cases, time is always an issue. There is always no much time for do it. We had a case where there was a really aggressive tumor, which needs to we needed to plan the operation, and we have 3 days for it, and we plan it. It was the reconstruction of the face of, and there wasn't needed for the custom-made implant from the titanium. So we prepare only the surgical guides for it. But I can show you. So the reconstruction was like this, if you can see how much of the face was reconstructed. And we also sometimes see that the surgical guides are really helpful for the surgeons to speed up the process, to speed up the surgery, to make it more precise and shorten in time. Of course, there are more benefits from that, but on the other hand, having anatomical models, what you all have said, is also important, because during the operation, the surgeons have it on the side and he see everything clearly. And imagine when you are doing the operation, you cannot see. There's a lot of blood, muscles, and what you have sometimes they have only small pieces where they can see that the bone. They have to find the right piece of it. So it's really hard during the operation. And having that in mind, even those anatomical models would really help during the operation. So that's important to have it on hospital, right? To prepare them for the cells even. Yeah. As Joyce said, when the surgeons see how time it takes to have these anatomical models, they see they can treat time in a different way. But also, it's really good to for them to have it on site.
Yeah, of course. When you bring the technology directly on site, it's better for them. Especially for the anatomical model, it may be easier than, for example, the implant and the surgical guides will require a post-processing that will be further will be more complicated.
But where is that line? Where is that point when surgeons can do them by themselves? As you said, they have their own lab in hospital. They can make anatomical models by themselves. They have their own software, printer, and engineers who will help them with that. But will they plan the surgical guides by themselves? Will they plan the implants? I think that they still here will need the experience bioengineers to have them.
Exactly. No, I completely agree with you. Especially, I think even if you are directly on the facilities of the hospital, you still need an engineer, the expertise. You can also bring your expertise of your company directly into the hospital to reduce the different back and forth. You are directly linked to the surgeon. But I think that's a really good point. You have the expertise, but also the time. A lot of surgeons know how to. Their experience with the surgical guides, and they are experienced with different softwares, but they don't usually have the time to do all the preparation, especially in 3 days. As you said, you took this example. During those 3 days, the surgeon is going to do all the preparation for her patient or his patient, and the planning is going to be to the engineers. You talked about the anatomical model and how it helps during the surgery. I agree with you, especially for the visualization of the anatomy. We have great question about this on the chat. Do you encounter any inaccuracies in your anatomical models due to source data or processing constraint? What is the source of those errors, and how do you mitigate them? How do you manage those errors? Maybe Joyce or Eva, if you have an opinion.
Yeah, I think for us specifically, for every application we have a scan protocol we prescribe. So minimal specifications that we want the scan to adhere to. Because we know, for example, if we receive scans with a higher slice thickness or a higher pixel size, that the anatomical models will become inaccurate. They will have this staircase effect, which will not be a true representation. And other issues can be metal. That's the most common one. If the patient already has implants, then you can have quite a lot of scatter, and then it depends, on the filters used or the settings, if the images are still usable or if the bone has become so, let's say, unrecognizable due to the scatter that you cannot really rely on it to still create a guide or an implant based on that surface, for example.
Eva, do you want to add something on that?
Basically, having the software in-house help us to prepare algorithms to eliminate such errors, because of course there is we have different kind of medical data, and depends on the cases. For example, for children, the CT scan the different parameters. So these data sometimes are not as good as we want it to be. So through our algorithms, we could make those data better.
Great. If I can just add on that, it will the quality of the data is going to be really important there for the anatomical model, and you can see it from the beginning of the whole process that we mentioned before, and you can work with the surgeon and the healthcare staff to see if you can find a solution around that. And as you said, Eva, with the software, you can also find tricks to fix those problems. You both talked about the oncology cases. Do you think you have more constraint when you have oncology patient? I think if they have a radiation between the scan and the final project, do you see do you see more constraint or accuracies, different of accuracies?
Well, I think a big difference in planning for an oncology treatment is that you plan with a safety margin, no? to make sure that, you do a segmentation of obviously the bone, but also the tumor, and then you make sure that you take a margin to eliminate any potential inaccuracies from, for example, a small shift of the guide on the bone, but also from growth of the tumor between the images and the surgery. If the surgeons puts too much pressure on his saw blade and it skives a bit, you want to avoid at all time that you touch the tumor. So it's a different mindset in planning than when you're doing a reconstructive correction for an osteotomy, where you're trying to really go for the best angle to reposition everything very closely aligned, instead of trying to resect as safely as possible without overdoing it and then giving the patient too much of a bone defect that then requires reconstruction.
Of course. And I think the anatomical model will help a lot. Also, after that, when you have your surgical guide, you can try it with the anatomical model to see if you have the accuracy that you wanted. We talked a lot about the software part and the different projects that we can find after that. What's great here is that we have different technologies of 3D printing that we use to produce those products. Can you give us can you talk about the materials that you select for the different project that you made for the surgical guide implant? It's obviously going to be titanium, but can you give us more details about this?
I'll start. So the orthopedic implants are titanium indeed. Well, our craniomaxillofacial implants also, all the implants are titanium. But we also have, for the guides, a small selection in the CMF area where we even print the guides in titanium because of the very high accuracy we want to reach there. But then for the most projects, we just use polyamide for the guides. And then there are bone models in polyamide or from a resin-based material. So the CMF skulls are also printed with SLA in a resin because then they can work with 2 colors, for example, to highlight an area.
On our side, of course, we do the patient-specific implants made from titanium alloy. And for the guides, we use the resin because it's really accurate, and you can have the guides in really very fast time for it.
Okay, and the implants are also do in titanium, right? I can add a bit about this. At Bone3D, we use different technology for the anatomical models and for the also for the simulators and the training models. It really depends on what you want to achieve, what you want to see. As I showed you before, we have surgical training models that are made with PolyJet technology, and we will have different materials with different hardness and different colors to mimic the behavior of the tissues. And all of those projects are developed with surgeons who look at the project and during the development phase and see if it's accurate to what they really experience on the body. And they help us choose the material that will be the most accurate and the most which will mimic most the behavior of the tissues. For the anatomical model, we also do polyamide, and also we can develop anatomical model with fused deposing modeling, the first technology of 3D printing, which can give us different accuracy, but still good models. It will really depend on the application that you want to the application of the anatomical model. Joyce, we have, I think that would be Joyce or Eva, we have question about the implants. If you want to talk more about the printing time, I think if you want also, you can specify more about the post-processing part of the implants. Do you hear me?
So
no, go ahead.
Joyce?
It's fine.
So in our cases, it depends on the printing time for an implant is usually, I don't know, 1-3 days, depends on the implant. I think the time-consuming part maybe be the part of designing the implant itself, because if we talk about, for example, craniomaxillofacial, the time is shortened down when we are talking about the hip, for example. It depends everything. Oh, of course, everything depends on the case. So I don't know, what is your experience, Joyce, here?
Well, it's very similar. I was going to add as well. It depends on the size of the implant. So a osteosynthesis plate for the mandible takes a lot less time, obviously, than a severe hip reconstruction implant. So there, I think the printing is probably the difference between about half a day to close to 2 days, where you put the printer on Friday on and you just start reprocessing the Monday after. But then for the hip implants, yeah, we go through a hip treatment. We do not have the huge hip ovens on site, so that also takes some time. And then there are a lot of processing steps to clear the powder, to polish the implants, to make sure that all the support structure is gone. So
Of course.
And the post-processing and the quality control. So yeah,
Yeah.
that's another part.
Quality control is a big step in, especially in the healthcare sector.
Yeah.
It will take time during the post processing, and it's a major step.
And
What-
I have one thought which I would like to share with you, because I was thinking about the process at the beginning, which we discussed, and we started with CT scan, MRI, general medical data, the thing that surgeon has always. Wouldn't it be great if they have, on the other hand, the anatomical models of the structures, for example, as a standard for medical healthcare, to improve the patient's experience with that, to make the communication with the patients and within the surgeon's team better? It would be really, really great if this part of our work, of all we do, would be a standard someday for the patient.
That would be really great. Yeah.
It would, because I don't know what is your experience here, but there are many of operations which doesn't need to have patient specific implant, for example, or surgical guides, because surgeons are experienced, but if they see this tactile model on the operating room near the patient, it's much easier for them to prepare, to speed up the operation. So I think it's good way for this. Yeah.
I completely
I
agree with
agree,
you.
but I think only 3D planning only for every patient would also be a first big step.
Yeah.
I don't think it necessarily needs already an anatomical model, but a 3D planning, that's for sure where we need to go to mass personalization. That we go beyond the X-rays for every patient. Yeah.
Yeah. Because if you have some broken leg, it's easy. But if you have the reconstruction, then it might be a harder. Yeah.
Yeah, I think what you said, Eva, about the visualization for the patient also, it could be a general anatomical model of the different pathologies, the different cases that you can have. Not especially for the patient. It's not necessary that it's his or her anatomy. It could be the case, like for example a fracture or any type of tumor or cancer. It could be a general model that the surgeon could present, and it will really help the education of the patient.
Yeah, but it depends also, because when we are talking, for example, we have surgeons who operate children, and they have scoliotic spines. So every case is different, and it's really hard. So for them, it's really necessary to have such model to present to their parents, to show them how it looks like, because they cannot imagine that. So I think it all depends on the cases, because, for example, if you have also a tumor and you need a reconstruction, for such people, it's better to understand what will be done during the operation, and in such hard time for them.
Yeah, it's also an educating tool, because for the parents, as you mentioned, for kids, I have one example in mind. When they have a distractor place on their mandible to do the distraction of their mandible, the parents have to manually do the processes every day, during the few months after the surgery. So it's really easier for the parents to understand it if you show them a model of the actual case.
Yeah.
Now we talked more about how anatomical models are used to educate patient, and how they are used for planning, do you have, I think we have just a few minutes if you want to talk more about the specific application and the benefits that you saw with the different healthcare staff?
Yeah, I think so. The whole process is, if you want to need it, if you want to look at it, you need to see the whole process, because sometimes surgeons said that okay, it's expensive for the patients. Sometimes patient-specific implants, okay, it's more expensive than the standard solutions. But if you look at the whole process from the beginning, when the patients have the patient-specific implant, which is perfectly matched to his anatomy, the time during the surgery is shortened. The surgeons are well prepared for it. You can minimize the whole operating room time with the staff capacity, so that the patient can recover faster than with standard solutions. Sometimes even you can avoid some revision surgery. And some post-operative complications, which occurs with standard solutions. We had such a young girl, and for example, if we are talking about mandible implants, the standard solution, okay, we have some kind of sizes, but if it's girl, for example, and even the smallest one wouldn't suit her. So imagine what would be next without the patient-specific medical devices in such case. And later on, okay, we can, if we speed up at that time, the pre-operative planning, the time of the operation itself. So for the hospital, it's also better to manage the time of the operating room capacity, and there are some savings. And what's more important here, the patient has the best treatment because it's suited to him, to her, and he can recover faster, and she can back to work faster. So you need to look at the process as a whole one, I guess, from my experience, as what we do.
I totally agree.
Yeah, I agree, and I think what to add still is that you're actually providing a solution for some patients who are close to being out of options. So patients with very severe bone defects, there is a limit to the amount of trabecular metal you can stack on top of each other to reconstruct a hip, for example. There's a point where it becomes too difficult to make the 3D puzzle in the OR by the surgeon, and where it's then a very nice solution if you can just have an implant that fits, that reconstructs the joint back to its native position, and that gets the patient back walking.
Yeah, and that's why it's so important work of talented bioengineers here.
That's a good note to end with.
Really admire it, because your work affects people's life, and this is incredible.
Yeah, that's wonderful to hear, seeing 3D printing change patient quality life. Thank you, ladies, for this great panel and discussion and answering our participants' questions. I would like to thank you and say this is the end of our panel. I will invite also the attendees to go to the main stage for networking. Please go meet Céline, Joyce, and Eva. Any table at the main stage and network, and take this topic further if you want, and enjoy the networking session. Thank you.
Thank you very much.